So you have just created your first Proxmox host, and life is good. You can host your own services like Nextcloud for your files, Jellyfin to replace Netflix, Vault Warden to secure your passwords, and you can save yourself some money. But you want more. One Proxmox host is nice, but three Proxmox hosts gives you more power and more resources. And combining these hosts into a cluster means you get redundancy and you can move your VMs around. So in this video, we're going to create our first Proxmox cluster. Alright, so let's dive in. Now, I'm currently logged into a Windows 11 machine, and if you ran the Proxmox helper script when you first created your Proxmox machine, and you turned off your cluster features like core sync and high availability, you will need to turn these back on. So let's go through how to do that. Now first, I will open up my terminal application, and from here I will SSH into my Proxmox system. And the commands we need to run are systemctl enable PVE cluster space core sync, and then systemctl start PVE cluster and core sync. And then we can do a systemctl status PVE cluster and core sync just to make sure that these are indeed running and they're active, which they are. Next, we need to re-enable high availability, and we can do that with these commands. So systemctl enable PVE-HA-LRM and PVE-HA-CRM and systemctl start PVE-HA-LRM and PVE-HA-CRM. And we can check the status with systemctl status PVE-HA-LRM and PVE-HA-CRM. Then, lastly, you can run the command systemctl restart PVE proxy and PVE daemon just to restart the Proxmox services related to the cluster features. And if you have other nodes that you ran the helper script on, you will need to run these commands on those other nodes as well. So what I will do is I will open a new tab in my terminal, and then I will SSH into my other node called PM2. And then I will just paste the commands that I'll be using into a text editor. Then I will copy it, and then I will just paste it into the terminal. So I could paste all these commands all at once, and then I just need to wait for it to execute. Then lastly, I will open up another tab, and here I will SSH into my third Proxmox node called PM3, and then I will paste the commands here as well. Alright, so that will restart the cluster service on all the Proxmox nodes. Next, I will log into the web portal, and I will do this for all three of my Proxmox nodes. And before we can enable the Proxmox cluster feature, we need to ensure that our time is the same for all three of our Proxmox nodes. Time is very important for our Proxmox cluster feature. If your nodes have different times, you can run into issues adding your nodes to your cluster. Now, to check the time, I can click on my Proxmox node, then go to time, and from here I can click on time zone, and then I can choose the time zone that I'm in. And I will do the same for PM2 and PM3 as well. And lastly, we need to ensure that our Proxmox nodes can resolve each other's hostname. Usually this can be done using a DNS server, but if you don't have access to one, this can be done using the host files on your Proxmox system. So I can click on PM1, and from here I can click on hosts, and then we can look at the second line. We'll be following this format to add our other two host names for PM2 and PM3. So I will add 172.20.20.51. This is the IP address for PM2. Then we'll add a space, and then we'll type pm2.infotech.tr.ca, and then pm2. And then we'll type 172.20.20.52, which is the IP address for PM3. And then we'll do a space and pm3.infotech.ca. And then we'll do another space and then type PM3. Then I will click on save to save my changes. Then what I could do is I could just copy these 3 lines and head over to PM2 and PM3 and just paste this line inside of the host file. And I will just select the current line that's there, and then I will override it with the 3 lines that I'm pasting in. And just to make sure my changes work, I can open up a terminal, and from PM1, I can ping PM2, and we can see that we do get a reply. So I'm using the host name instead of the IP address. I can press Ctrl+C to stop the ping, and then I will ping PM3. But here I will add a -C3 at the end so that it just sends 3 packets. And we can see that this is working as well. Then I can head over to PM2 and I can do the same. So we can indeed ping PM1 and PM3 from PM2. And then lastly, I'll head over to PM3 and then I will ping PM1 and PM2 just to make sure that all these hosts can communicate with each other. Perfect. We can communicate between our nodes using their respective host name. Now it's time to create our cluster. So I will head over to the GUI portal for PM1. We'll click on Data Center, then Cluster. Then I will click on Create Cluster. My cluster name will be PM-cluster, but you can name yours something different. We'll leave the link as 0, and then we'll click on Create. And that is it. We've just created a Proxmox cluster. Now we need to join PM2 and PM3 to our Proxmox cluster. So first I will close this window. Then I will click on Join Information. Then I will click on Copy Information. We'll head over to PM2. We'll click on Data Center and then Cluster. And then we'll click on Join Cluster. Then I will paste the join information. Ensure the peer address is PM1's IP address. Then we'll enter the root password for PM1. Ensure this is the root password for PM1. If the passwords for all of your nodes are the same, then you'll be fine. Then we'll click on Join PM Cluster. And from here, it will join the cluster for us. Now what I will do is move the Join Cluster window down a bit. And we will see that we get this permission deny message popping up. And then we get another connection error message. However, if I were to head over to PM1, I can see PM2 under Data Center, which tells me that PM2 was added to our cluster. Then if I head back over to PM2, I can refresh the page, sign back in, and I can see the PM1 node and PM2 in the same portal, which means that this did work despite the error message. And then we'll head over to PM3 and we'll do the same thing. We'll go to Data Center and then Cluster, then click on Join, paste the join information, and then enter the root password for PM1. And then we'll click on Join PM Cluster. And we get the same permission deny message followed by the connection error. But if I were to refresh and sign back in, and if you can see all 3 nodes under Data Center, then this is a good sign that it did work. Alright, so let's head back over to PM1. And because my other 2 nodes are within my PM cluster, I'm able to manage those nodes from here. I can click on the PM2 node, I can look through the different options, then I can click on the Shell tab, and I can enter commands here. I can type app update -y to refresh the repositories. I do get a few error messages here because I don't have my correct repositories configured, but I can change that. I can click on repositories, I can disable the enterprise repositories, and add the no subscription repository. And then if I try the update once more, we can see that that works. So we can refresh repositories, but we can also upgrade the system as well, which I will do. And I can do the same thing for PM3. I can modify the repositories, and I can update the system. So right away, we can see a benefit of having our nodes in a cluster. It's easy management for our system. I can update and upgrade the system, I can look through the options, and I can make any changes that I want from one single management console. So, enabling the cluster feature in the GUI is very straightforward and easy. As long as your nodes can resolve each other's hostname and the time is consistent, you should have no trouble creating your cluster and joining your nodes to the cluster. Now, I want to show you how to do this using the shell. You never know, one day you'll get an IT job and you might find yourself inside a server room with direct console access to your Proxmox server and you need to enable the cluster feature without a GUI. So let's look at how we can do this. So back on my Windows 11 machine, I will launch terminal and then I will SSH into my PM1 node. My instructions for restarting the cluster features and high availability are the same, so I won't be repeating these commands, but we still need to be able to resolve the host names for each of the nodes. And the command for this is nano /etc/host. And from here, it's the same idea. We just need to add the IP address and the host name for PM2 and PM3. So I will do that. And then once I'm done, I will copy these lines. Then I will paste it into my notepad text file. Then I will SSH into PM2. And then I will edit the host file here as well. I will press Ctrl plus K to delete the current line. Then I will paste my 3 lines. And then I will press Ctrl plus O to save. And I need to save it on PM1 as well, so I'll head over there and do that. And then we'll SSH into PM3 and we'll do the same step. Then we'll just ping PM1 to ensure that we can indeed communicate with it. Alright, so that's one step down. Next, we need to configure our time. So I will head back over to PM1 and the command we need is time date CTL. And this will show us information about our time. And we can see our time zone is America/Toronto, which is correct for me. But if this wasn't correct for you, and you need to see all the available time zones, you can use the command time date CTL space list dash time zones. And this will show me all of the time zones that's available. So let's say, for example, that I need to change my time zone to America/Thunder_Bay. I can press Q to exit out of here. Then I can type the command timedate CTL space set dash time zone space America/Thunder with a capital T underscore Bay with capital B. Now, just a FYI, Linux based systems are case sensitive. So ensure that you type the text exactly as it is with the correct capital letters. Then we'll do another time date CTL, and we can see that my time zone indeed did change. But I will need to change this back to be America Toronto because that is the time zone that my other 2 nodes are in. Alright, so DNS is good and time is good. So now we can enable our cluster feature. And the command to do this is pvecm space create. And now we can name the cluster. So I will name mine PM-cluster. And then we'll wait for the cluster to be created. And once that is done, we'll enter the command pvecm space status. And this will show us some details about our cluster. For the quorum information, we can see nodes 1. And the membership information, we can see our node with our IP address. So now that our cluster is created, let's add PM2 and PM3 to our cluster. So we'll head over to PM2, and the command to join the cluster is pvecm add and then the IP address of PM1, which is 172.20.20.50. And then we'll enter the root password for PM1. Then we'll say yes to continue the connection. And once the password is accepted, PM2 will be joined to the cluster. And unlike the GUI, we don't get any error messages about permission denied or connection error. So once that is done, we'll then head over to PM3, and now we'll do the same command. And once PM3 is added to the cluster, I'll head back over to PM1. And here I'll run the command pvecm status once more. And we can see under quorum information, we now have 3 nodes. Under membership information, we have 3 nodes there as well. I can also enter the command pvecm nodes, and this will show me just the membership information, and the command ha-manager status. And this will tell me that the quorum is in an OK status, which is good. I can now head back to my GUI, and we can see our 3 nodes available to us in the PM1 console. I can also click on Data Center, then Cluster, and I can view my nodes here as well. All right, so we got our cluster up and running, which is great. We can now manage all of our nodes from just one GUI. So this makes management much easier for us. But what other benefits do we get from a cluster? Well, currently we can use 2 features. We can use the migration feature and we can use the replication feature. So let's look at those. And for this demo, I've added a new 100 gigabyte disk in each of my Proxmox nodes. And I will be using these disks to create a new ZFS resource. For replication, you need either Ceph or ZFS for the feature to work. And since we haven't configured a Ceph storage as yet, ZFS is our next best option. So we'll click on PM1, then we'll click on ZFS, and then we'll click on Create ZFS. And since we'll be testing out high availability, we'll name this ZFS-HA, and then we'll check the box to select our device, and then we'll click on Create. Then I'll do the same thing for PM2 and PM3. And when I'm naming these devices, I'm giving them the same name because for live migration and replication, Proxmox works better when your storage ID is the same name. And once I am done, I can click on Data Center, then Storage, then ZFS-HA. I will click on Edit, and we can see our nodes here are PM3, PM2, and PM1. Now, don't let this confuse you into thinking that Proxmox combined these drives together. It did not. These drives still belong to their respective nodes, but it's just grouped together because the storage ID, which is ZFS-HA, is still the same. Then I'll head over to my PM1 node, and here we'll click on Local, and then City Templates, and here I will download a new Ubuntu template. Then I will click on Create City, and now I will create a new container. We'll name the container Ubuntu-VM. We'll create a password. And I do have this option to enable high availability. And if you're using a cluster, you definitely want to enable this feature. But I also want to show you how to enable it in case you forget to check the box during creation. We'll click on Templates, and we'll select our Ubuntu template. Under this tab, we'll change the storage to be our ZFS-HA resource, which is important for our tests. And we'll change our disk size to be 10 gigabyte. For CPU, we'll leave it at 1 core. For memory, I'll increase it to be 1024 megabytes. For network, we'll select DHCP. And then we'll leave DNS as is. We'll check the box to start after created, and then we'll click on Finish. And then we'll wait for the creation to be completed. And once our Ubuntu container is created, I will sign in with my root credentials. And once I'm signed in, I will type the command app update-y just to confirm that our container is working. All right, now let's say that I want to shut down PM1 because I need to update it or I need to perform some physical hardware changes. Now, usually if we just have this one node, I will need to shut down my VM along with PM1. But we have a cluster with 2 other active nodes that we can utilize in this situation. And I'm not sure if you've noticed, but we have a new option called Migrate. So I can click on that. Then we have the migration window open up. And here it's asking me what I want my target node to be. And it's currently set to PM2, but I can also change this to PM3. Obviously, I won't be able to select PM1 because that is where the node is currently on. The mode is restart, which means that Proxmox will shut down the VM before it migrates it, and then turn it back on once the migration is completed. Now, if we had shared storage available, we would have been able to migrate this VM without shutting it down. But we'll leave that topic for our next video. I will click on Migrate, And now we can observe the output of the task viewer. The first line is Proxmox shutting down the container. The second line is Proxmox starting the migration. And if you look through the remaining output, you will see that Proxmox is sending the VM over to PM2. And the second to last line tells us that the migration is finished successfully. And we can see that. Below the PM2 node, we can see the Ubuntu container has been migrated over. And I can log in and once again run the app update command, and we can see that it works. Our container is now active on PM2. So this was the migration feature. And even though Proxmox had to shut the container down first before it migrated it, you can still see the usefulness of this feature. And one other thing to know is we migrated a container, so it was fairly quickly. Usually the more RAM your VM has, the longer the migration will take. So just a note for the future. Now, this was a planned shutdown. We knew beforehand that we were shutting down PM1, so we were able to plan for it. But what if it was unexpected? Maybe a power outage, or a system crash, or something happened to our node that caused it to go offline. Well, in that situation, the container will also be powered off. However, another feature we get from the cluster service is replication. And for this to work, we need to ensure that we have high availability enabled for our virtual machine. Remember, when we create a new virtual machine or container, we have this option to enable high availability. I did not check this box when I created our Ubuntu container, but I can click on More. Now ensure that your container or VM is selected here. And then I can click on Manage HA, and then I can just click on Add. Then we'll click on the Replication tab, and here we'll click on Add. We'll leave our target to be PM1, but we could change this to be PM3 or another available node. We can click on Change the schedule for the sync. The default is every 15 minutes, so I will leave it at that. Then I will click on Create. And then I'll wait for about a minute, and I can see that the sync is started and it was completed. Now, if I click on ZFS-HA under PM1, I can see a subvol here. And this subvol was created by the replication feature. Now what I will do is open the terminal application, and on the PM1 SSH session, I will type the command watch-n 1ha-manager status. Now we can see live information about our nodes. And we can see PM1 and PM3 are idle, and PM2 is active. So we'll head over to the PM2 SSH session, and I will type the command power off. And this will shut down the PM2 node. And then we'll head back over to PM1, and now we'll watch and see what will happen to the PM2 node. First, the status will change from active to shutdown, then to OL timestamp and dead with a question mark. So what is happening here is the Proxmox cluster is trying to communicate with PM2, and PM2 isn't responding because it's powered off. And eventually what will happen is the Ubuntu VM replication feature will notice that PM2 is off, and then it will move it over to PM1. And we can see under service that this will change from PM2 started to PM1 starting and then PM1 started. And we can see this in the GUI as well. The Ubuntu container is now under PM1. And for one final test, we'll just sign back in with our root account on our Ubuntu container. And then we'll just run the app update command once more, just to make sure that our virtual machine is indeed active. Alright, so that is it for this video. We've enabled the Proxmox Cluster service using a 3-node configuration. We were able to manage all of our nodes from a single GUI session. We saw how to migrate VMs from one Proxmox node to another, and we saw how replication works to add some redundancy to our VMs and containers. Now, this is a good start if you're learning about containers and virtual machines. However, there is still more to know. In the next video, we'll look at different kind of Proxmox storage and how we can configure and create them. So I will see you in that video. Thank you for watching.